Hello everyone, I am Reshma Ravindran. Welcome to Mathify. Today we will be discussing a very important topic in mathematics, algebraic expressions and equations. So let's start our session with a small story. So, some friends are going to this carnival. Okay, and this carnival consists of so many stalls. Game stalls were there, food stalls were there, activity stalls were there, and these friends decided to go to a candy store. Okay, and this particular candy store had two counters, one for buying the coupons and the other for getting the candies. And there was an offer, as many coupons you buy from the first counter, you will get that many number of candies plus three more extra candies. That's a good offer, right? Okay, so these friends decided to go and get some coupons. Okay, so did you understand? That means if a person buy one coupon, then that person will get one candy, and along with that, that person will get three more extra candies. That means 1 plus 3. So let's see how. Coupons, candies. If a person get one coupon, then that person will be getting 1 plus 3, 4 candies. If another person buys three coupons, then that person will get 3 plus 3, 6 candies. Okay. So here we can establish a relationship between coupons and candies. Okay, let's take a variable for that. If I take X for the number of coupons, that means if a person buy X number of coupons, then that person will be getting how many candies? Yes, X plus 3 candies. See, here we have established a relationship between coupon and candies. Number of coupons and number of candies. And we got something like this, X plus 3. And this is algebraic expression. Okay, so algebraic expression comes under this category of mathematics, algebra. And what is algebra? Algebra is a branch of mathematics that uses mathematical statements to describe relationship between things that vary. Here, what was varying? The number of coupons, right? So number of coupons was varying and one thing was fixed. What was it? That offer, three extra candies, right? So algebra is a branch of mathematics that establishes a relationship between quantities, and among that one quantity will be varying. So many real world applications are there for algebra. Interiors and landscape designing, computer programming, business and finance management, cooking, sports, etc., etc. Because in most of the fields we had to establish a relationship between quantities, right? So most of these things come under real world applications of algebra. So now let's get into some key terms. Okay, so variable is the first one. So earlier we saw an algebraic expression. What was it? X plus 3. And here, see, we have already discussed what was varying. This X, that means number of coupons was varying, right? So this is the variable. Okay, we usually represent variable using letters or symbols. Most often we use alphabetic letters to represent variables like X, Y, M, A, B, etc. And next is constant. What was constant in our example? X plus 3. Here, the number of extra candies was fixed, right? We have no right to change that, right? So, this 3 is known as constant. And constant remain same throughout the expression. We have no right to vary that. Next key term is coefficient. Okay. So let's write an expression 2x plus 5. Here, 2 is multiplied to this variable, right? So this 2 is known as coefficient of x. 2 is known as coefficient of x. Here, one more example is given in the expression 4x. What is the coefficient? 4. Okay, so we have learnt three basic terms: constant, variable, and coefficient. Now comes another thing, terms of an expression. Okay, in algebra, this algebraic expression is made up of one or two or multiple terms. Okay, and these terms are combined in an expression through two symbols or two operations, addition and subtraction. See, here there is an example 3x plus 2y minus 5. So here you can see a plus sign over here, right? So that means 3x is one term and 2y is another term because here one minus is also visible. So 5 is another term. Okay, so this plus and minus separates the terms. Okay, addition and subtraction separates the terms. Let's see another example. 4x minus y. Only one sign is here, right? Minus. So 4x is the first term and y is the second term. So in total, two terms are present in this particular expression. So let's do an activity based on this. Okay. 4x square plus 5x plus 3. How many terms are here? Here you can see plus sign. Here you can see another plus sign. So 1, 2, 3. Three terms are present. And what about this expression 2y minus 3x? Here, minus is separating the terms. This is first term, this is second term. So, two terms. And here, what about this? Can you see any plus or minus sign in between 10 and x? No, right? What does 10x mean? What does it mean, 10x? 10 into x. So, this is a single term because no plus or minus sign is present here. So, this is one term. And one more thing, based on the number of terms, algebraic expressions can be classified into several categories. If an algebraic expression is having one term like this one, that expression will be called monomial. Okay? Monomial. You know, mono means one. Now, if an expression containing two terms, then it will be called binomial. By two. So, binomial. And if an expression contains three terms, it will be called trinomial. Okay? So, these are something that which is very important for algebraic expressions. Now, like terms. Okay, next topic is like terms. Like terms are terms in algebraic expressions that have the same variables raised to the same powers. Okay, so that means, see, 2y square and 7y squared. Here variable is y and it is raised to the same power, right? Y square, y square. So these two are like terms. Any other example? See, if I write 4x and 7x. See, x is raised to the power 1. Here as well, x is raised to the power 1. So 4x and 7x are like terms. And what about 3x and 9x square? Here, variable is same, x and x. But here in this case, x is raised to the power 1 and in this case, x is raised to the power 2. So that means they are not like terms. So what do we call them? Unlike terms. So the terms which are not like are known as unlike terms. Unlike terms are terms in algebraic expression that have different variables or same variables but with different exponents. For example, 4x and 9y. See, 4x and 9y. They are having two different variables, x and y. So they are unlike terms. And in this case, 2x square and 5x cube, they are having the same variable, right? X. But the first one is raised to the power 2 and the second one is raised to the power 3. So they are unlike terms. So by now what we have discussed so far, algebra, algebraic expression, and what is constant, variable, and coefficient, and what do you mean by terms of an algebraic expression? How can we separate the terms? How can we find out the number of terms present in an algebraic expression? And then we found out what's the difference between like terms and unlike terms. Now we are getting into a main topic. Operations on algebraic expressions. We can do all the four fundamental operations on algebraic expressions. What are those fundamental operations? The basic operations: addition, subtraction, multiplication, and division. Okay, so let's see one by one. First of all, addition. So there are some steps. See, let's read the steps. Identify like terms, combine like terms, operate on like terms. Confused, right? So let's see a question. Then this will be clear to you. See, this is our question. Add 3x square plus 5x minus 7y plus 10 and 2x square minus 3x plus 2. Okay, we are supposed to add these two expressions. So let's add these two expressions. 3x square plus 5x minus 7y plus 10. And we have to combine the first and second expression using which sign? Addition, right? So, plus. Now, 2x square minus 3x plus 2. Now, let's get back to the previous slide. Identify like terms. So, what are like terms here? 3x square, 2x square, right? Then what is the next like term? 5x, 3x. Yes. Then, yes, 10 and 2. They are constant terms. And y term is only one y term is here. Okay. So we have identified the like terms. Now what's the next step? Combine like terms, then operate. Okay. So we have identified. Now what are the next two steps? Combine and operate, right? Okay. So let's combine. 3x square, it will be combined with the like term 2x square. And if you want to write or pick an expression, if you want to write a term, then you have to take the same sign. Okay, when you write the term somewhere else, you have to take the same sign and put it along with that term. Okay, now 5x. So plus 5x. Plus 5x. Then here minus 3x. Then comes minus 7y. Then the constant terms 10 and 2. Plus 10 plus 2. Now operate. Let's operate on them. Okay. So we understood the difference between like terms and unlike terms, right? The major difference between like terms and unlike terms is this. Like terms can be combined. Like terms can be added. Like terms can be subtracted. But unlike terms cannot be combined or cannot be subtracted. Okay. So here, so that's why we have categorized it. We have picked out the like terms and wrote it together. So 3x square plus 2x square. How many x squares are here? 5x square. Next one. 5x and 3x. Yes, 5 minus 3, 2, then x. Now only one y term is present, so we can write as it. Now 10 plus 2, yes, 12. So the sum is 5x square plus 2x minus 7y plus 12. Okay. Now comes subtraction. So here are also some steps. Distribute the negative sign, identify like terms, combine like terms, operate on like terms. Let's see the question. Subtract 7x square plus 3x minus 4xy plus 2 and 5x square minus x plus 6y minus 2. Okay, so what's the first expression given? This one, right? So we can write down the first expression. 4xy plus 2. Then we have to put minus symbol. Why? It is subtraction. Then we can write the next expression. And before that, I wanted to tell you something. If they use from term instead of and, then you are supposed to write this expression first. Okay. Subtract the first one from second one. If the question was like that, you should have taken the second expression first. But here, no term like from is here. So you can take the first expression. Now, we are supposed to write the next expression here, right? So we have to put them inside a bracket. 5x square minus x plus 6y minus 2. Okay. So, if you want to write an expression after negative sign, minus sign, then you are supposed to put that inside a bracket. Okay. So, why we are doing like this? We have to distribute the negative signs here. Okay, I will explain that to you. First, we can write this expression as such. 7x square plus 3x minus 4xy plus 2. Now we have to distribute this minus sign. Minus into plus 5x square. What will be the answer? Minus 5x square. Now, minus into minus x. What will be the answer? Plus x. Now, minus into plus 6y. So, minus 6y. Now, minus into minus 2. That is plus 4. So, we have distributed the negative sign. So, first step is over. Now, identify, combine, operate like that of the addition of expressions, algebraic expressions, right? Okay. So, we can pick out the like terms and write it together. 7x square. Okay. We wrote 7x square. Now minus 5x square. They are like terms, right? Now next one. 3x is here. X is here. So plus 3x plus x. Now, okay, only one xy term is present, so you can write minus 4xy. Then only one y term is present, so you can write minus 6y. Then comes the constant terms 2 and 4. So plus 2 plus 4. So we have picked out the like terms, we have combined it. Now it's time to operate. 7x square minus 5x square. What will be the answer? 7 minus 5, 2x square. Now, 3x plus x. Yes, 4x. Now, minus 4xy. Then comes minus 6y. Then comes 2 plus 4, which is 6. So, the difference is 2x square plus 4x minus 4xy minus 6y plus 6. Now, next one is multiplication. So, before getting into multiplication, I would like to add something. See, in every problem, there is a basic level and advanced level. So, this is since this is our first session on algebraic expressions, I have chosen only the basic questions and basic topics. Okay, so we will be discussing the advanced topics in next sessions. So, for that, what you need to do? Please subscribe and click on the notification bell. Okay, so now it's time to learn multiplication. Multiplication. See, here two binomials are given, right? What do you mean by binomial? An algebraic expression containing two terms. So here as well, two terms. Here also two terms. So here we want to multiply these two binomials. Let's write the question. 3x plus 2y. The next expression is 4x plus 5y. Each expression is having two terms, so we can just put them inside a bracket. Okay. And here we need to follow a rule. This one. Multiply each term in the first expression by each term in the second expression. Okay, I will tell you here two brackets are seen, right? We have to use distributive property. We have to distribute each member in the first bracket among the members in the second bracket. Okay, let me tell you how. Let's start with 3x. 3x should be multiplied with 4x. Okay, 3x into 4x. 3x into 4x. Next one, 3x should be given to 5y as well. So plus 3x into 5y. Now, the first one is over. Now, which is the other member? 2y. 2y should be given to the members in the other bracket. Plus 2y into 4x. Next one, 2y into 5y. So, 2y into 5y. Okay. How will you do this? 3 into 4. 12. X into x. X is multiplied 2 times, right? So, x square. Now, 3x into 5y. 3 5s are 15. X into y means xy. Now, here, 2y into 4x. 2 4s are 8. Y into x. That is xy itself, right? How? Xy is same as yx. Which property is used there? Commutative property. 2 into 3 is same as 3 into 2, right? Okay. Now comes 2y into 5y. So 2 5s are 10. Y is multiplied 2 times. So y raised to 2. Can we simplify this? X square term is here. Xy term is here. Another xy term is here. Y square is here. So you can combine these two, right? Why? They are like terms. So 12x square plus 15 plus 8. What is it? 23xy plus 10y square. Okay. This is the answer. Now comes division. Okay, so let's read the question. Divide 6x square minus 9x by 3x. Okay, let's write this. 6x square minus 9x divided by 3x. Okay, now 6x square minus 9x. Can we take any common factor outside? 6 and 9. What's the common factor there? 3, right? Why? 3 2s are 6 and 3 3s are 9. So you can just take 3 outside. Now, any common among variables? X square and x. So you can take x outside. Now, what else is left? 2x minus 3, right? When you take 3x outside from this expression, you will get 2x minus 3 divided by this thing. 3x. See, 3x and 3x. Same terms in the numerator and denominator. So you can just cancel it out. And what is remaining? 2x minus 3. So 2x minus 3 is the quotient here. So we have covered all the 4 fundamental operations. Now comes the next important topic, algebraic equations. Okay, so what do you mean by equation? Simple definition is a mathematical statement containing an equal to sign, right? 2 plus 3 is equal to 5. This is an equation. Okay. And if you add some variables to it, 2x plus 3 is equal to 5. Okay. And this becomes algebraic expression. Okay. So algebraic equation, not expression. Here equal to sign is present. So it becomes equation, algebraic equation. An algebraic equation is a mathematical statement that asserts the equality of two expressions. Okay, if I have two expressions like 2x is first expression, now next one is x plus 5. If I can equate it with equal to sign, and this is an algebraic equation. Next is solving equations. Okay. So, what do you mean by solving an equations? Algebraic equations will mostly contain variables, right? So, the process of finding out the values of those variables present in the equation is known as solving equations. So, solving equation means just to find out the value of the unknown variable, the variable present in the equation. Let's see some questions. Okay, so first question, x plus 5 is equal to 7. How will you do this? Okay, so let's write the equation first. X plus 5 is equal to 7. We have to find out the value of x here, right? No doubt on that, right? Okay, so, in order to find out the value of x, we don't need the other numbers, like we don't need this 5, we don't need this 7. So, we want to eradicate all these from our question, our equation. So, let's do. How will I eradicate this 7? Remove this 7. Positive 7 is here, right? So, if I subtract RHS with minus 7, then that 7 will be gone, right? So, let's see. X plus 5 is equal to 7 is here. So, I don't need this 7. So, I am subtracting another 7 from this. Okay. So, whenever I make a change to any of the sides in an equation, whether it may be LHS or RHS, I have to do the same change in the other side as well. So, here I added minus 7 in RHS. So here as well in LHS, I had to add minus 7. So what will be the answer? RHS will be 0. This will be x minus 2, right? Okay. So x minus 2 is equal to 0. Now I don't need this 2. So I want to remove that 2. How will I do that? Minus 2 is already present. I have to add 2 to this place, and this one will be 0 plus 2. So, in short, x is equal to 2. See, we thought like this and we found out the answer, right? So, I will tell you a better way. Okay, I will tell you a better way. Let's remove this. Okay, actually, we don't need to get confused like this. This is very simple equation. So we can solve it very quickly. Actually, something called inverse operation can be applied over here. Okay. Here we need to find out the value of x. So we can write the equation x plus 5 is equal to 7, and we need to find out the value of x. So let x be kept here. Now we have to move every other constant to the other side. So 7 is already present in RHS. Now we have to move this 5 to RHS. Okay. So inverse operation is like this. Whenever you move a number or a term across the equal to sign, then that operation changes. Here plus is present, right? So when 5 moves to RHS, it will become minus 5. So 7 minus 5 is 2. See, simple, right? Solution of the equation is x equal to 2. Let's see this one. Y minus 2 is equal to 10. So we need to find out the value of y. So let's keep y here. Now we can move all other numbers to the all other terms to the RHS. So 10 is already present in RHS. So we don't need to worry about 10. Now minus 2 is present. We have to move this minus 2 to RHS. See, minus 2 is present. Subtraction. So what will be the inverse operation? addition. Inverse operation of addition is subtraction. Subtraction is addition. Multiplication is division. And division's inverse operation is multiplication. Okay. So y is equal to 10. Then this minus 2 will become plus 2. So y is equal to 12 is the solution. Okay. Let's get into another question. 4x equal to 24. Here we need to find out the value of x. So we can write the equation first. 4x equal to 24. And now we can keep the x on the LHS. Okay, 24 is already present in RHS. Now, 4x. What do you mean by 4x? 4 into x, right? So here multiplication sign is present. So when we move this 4 to RHS, what will happen? It will be divided by 4, right? So since this is a numerator, it will come to denominator. 24 by 4. 4 1 is 4, 4 6 are 24. So solution is x equal to 6. Okay, now next one. 2y by 3 is equal to 10. How will you do this? We need to find out the value of y. So let's write the equation first. Now we can keep the variable term. Here the variable is present, right? Sorry, the coefficient is present, right? So we can keep the variable term as such. Now we can move this 3 to RHS. 3 is in denominator, so it will go to numerator. That means division will become multiplication. So 10 is already present here and this 3 will become into 3 which is equal to 30. 2y is equal to 30. Now what we can do? Y can be kept here 30 and this 2 will become divided by 2. 2 1 is 2, 2 15s are 30. So y is equal to 15 is the solution. You can reduce the steps. Okay. Since I'm explaining everything step by step, I'm writing lots of steps here, but no need to write every step. You can reduce the number of steps. Next one. 3x plus 6 equal to 15. How will you do this? 3x plus 6 equal to 15. We can keep the variable term here. 3x equal to 15. Now 6 can be moved to RHS. So it will become minus 6. 15 minus 6 is 9. So 3x equal to 9. Now we have to find out x. So x can be kept in LHS itself. Now 9. Then what happened to this 3? Into 3 will become divided by 3. 3 1 is 3. 3 3s are 9. So the answer will be x equal to 3. So solution is x equal to 3. Understood? Okay, let's see another question. 5a minus 2 is equal to 23. Let's write the equation. 5a minus 2 is equal to 23. Let's keep the variable term over here, 5a. Now 23 is already in RHS. Now what will happen to this minus 2? It will become plus 2. Okay. So 23 plus 2 is 25. Now 5a is equal to 25. What will happen to our a? A is equal to 25. Here, into 5 will become divided by 5. 5 1 is 5. 5 5s are 25. So, A is equal to 5 is the solution. Next one. Here, a bracket is visible, right? But this is very simple. 5 into x plus 4 is equal to 45. We need the value of x, right? So we can keep the bracket here itself. Now, what's the extra thing? This 5, right? So this 5 should be moved to RHS. 45 is already present in RHS and 5 into this bracket, right? So when it comes over RHS, it will be in the denominator divided by 5. 5 1 is 5, 5 9s are 45. So the equation gets simplified to x plus 4 is equal to 9. Now this is a very simple equation, right? We can find out the value of x by keeping x here. Then 9, this plus 4 will become minus 4. So the answer will be 5. X plus 5 is the solution. Now, this one. 6b minus 1 is equal to 6 times b minus 1 is equal to 42. 6 times b minus 1 equal to 42. We can keep the bracket here because variable is present inside the bracket. Now 42, then what will happen to the 6? Yes, like the previous question, it will be in the denominator. 6 1 is 6, 6 sevens are 42. So b minus 1 is equal to 7. We can find out the value of b. 7 minus 1 will come over here. So it will become plus 1. So b is equal to 8 is the answer. Okay. So this is the next question. 2x plus 4 whole divided by 4 is equal to 6. How will you do this? Let's write the equation. 2x plus 4 by 4 is equal to 6. Now we need to find out the value of x. So we can keep the numerator here. Okay. 6 is already present in RHS. 4 can be moved to RHS. So into 4. 2x plus 4 is equal to 6 fours are 24. Now we can keep 2x here, 24. This 4 will become minus 4, which is equal to 20. So 2x equal to 20, x equal to 20 divided by 2, which is equal to 10. Similar question. 7m plus 1 by 5 is equal to 3. We can keep 7m plus 1 here, 3, then 5 will become into 5. 7m plus 1 equal to 15. 7m equal to 15 minus 1, which is equal to 14. So m is equal to 14 by 7 is equal to 2. Okay. So, see, we have seen 10 questions now. And here, can you find out any difference here? Variable terms are present in both LHS and RHS, unlike our previous questions, right? Okay. So, how to do this? This is also very simple. Since more than one variable term is present, we have to move all the variable terms to one side and all the other terms to other side. Okay. So here two variable terms and one constant term are present. Let's write the equation. 5x plus 4 is equal to 3x. Now we can move all the variable terms to one side. Let's say left side. Okay, 5x. Now 3x can be moved to LHS. So it will become minus 3x equal to 4 can be moved to RHS because 4 is the only constant present. So plus 4 will become minus 4. Now 5x minus 3x. What's the answer? 2x equal to minus 4. X equal to minus 4 divided by 2. 2 1 is 2. 2 into negative 2 is negative 4. So x equal to negative 2 is the solution. Similar question. 2a minus 4 is equal to minus 10a. In this equation also, variable terms are present in both LHS and RHS. So let's write the equation. 2a minus 4 is equal to negative 10a. 2a plus 10a. Why? We have moved this 10a to LHS. Why? Because we are bringing the variable terms together. Now, negative 4 will come over here. So, it will become positive 4. 2a plus 10a is 12a, then 4. A is equal to 4 divided by 12. 4 into 1, 4 into 3. So the answer is A is equal to 1 by 3. Okay, so we have done a dozen of questions. So, as I said earlier, these are very basic questions. Okay, so we will be discussing more advanced level questions in upcoming sessions. Thank you.